In this example, I'm going to simplify spatial-temporal clustering using the 2007 to 2018 dataset from the Lending Club. And as you can see, this dataset is available and can be downloaded from the Kaggle website. So, after you downloaded the dataset, and it's a very huge dataset, it has about 1 million to 2 million cases or loans. And if you do a frequency on the purposes of loans, you are going to discover that usually people go through Lending Club for these 5 main purposes. Either they want to consolidate their debt, or they want to pay off their credit cards, or they want to borrow money for home improvement, or they have a major purchases, or they want to pay off their medical bills. So these are the 5 main purposes of peer-to-peer lending or borrowing. Before we perform spatial-temporal clustering, we first plot the trends in the total number of loans for each state. And as you can see from this figure, states like California, Florida, New York, and Texas, you can see for these 4 states, there's an obvious increasing trend in terms of the number of loans related to debt consolidation. And if you look at this diagram again, we can also see that for states like Arizona, Colorado, Georgia, Illinois, Indiana, Massachusetts, Maryland, Michigan, Minnesota, North Carolina, New Jersey, Ohio, Pennsylvania, Virginia, and Washington, we can also see a slight increasing trends from 2008 until 2018 for these states. So, why do we see an increasing trends in people taking out loans for debt consolidation? A few on several macroeconomics indicators may be affecting these trends, and I listed some of them here. Maybe there's a stagnation or declining trends in real income. And if these trends occur in tandem with declines in purchasing power or even inflation, people, individuals, you and I, may find it difficult to meet our needs. And sometimes we may have to resort to peer-to-peer lending, which is a very convenient way to get access to credit to meet our daily needs, given these trends. And another contributing factors could be increase in the number of contractual workers. We all know, most of the time, contract employees, they don't get health benefits or life insurance, 401k, or other benefits from employers. And when this happens in tandem with declining trends in real income or declining purchasing power, borrowers may resort to peer-to-peer lending to meet their needs. And this kind of lending platform connects borrower and lenders together through an online exchange, and borrowers and lenders do not have to go through the financial institutions. And despite the higher risk associated with this lending platform, lenders also find peer-to-peer lending appealing because of the higher expected returns and lower transaction costs, as they don't have to go through the bank. A loan may be charged off when the borrower defaults on the loan and there is no longer a reasonable expectation of further payments. So when this happens, the lender incurred a loss because in most instances, these loans are not guaranteed under peer-to-peer lending platforms. When we plot the trends of the number of charged-off loans for each state, we see that states like California, Florida, New York, and Texas, these states have an obvious increasing trend with respect to the number of charged-off loans. I'm sure you realize the trends in each state are very similar to the trends we just saw in the total number of loans for debt consolidation. And we also see in other states like Arizona, Colorado, Georgia, Illinois, Indiana, Louisiana, Massachusetts, Maryland, Michigan, Minnesota, North Carolina, New Jersey, Ohio, Pennsylvania, Virginia, and Washington. These several states experience a slight increase in the number of charged-off loans, and then we see the trend decline again. And once again, I'm sure you notice the trends for most of these states in terms of charged-off loans are very similar for the trends for these states with respect to the total number of loans for debt consolidation. We have to do two things before we can proceed to spatial-temporal cluster analysis. First, we have to convert the data into a matrix form, like the one below you just saw. And after that, we calculate the distances among the different observations states in this case, using the dynamic time warping metric. The dynamic time warping metric is used because it provides a more accurate calculations of distance among different states than the traditional Euclidean method. And I will do a comparison between the dynamic time warping metric and the Euclidean method in another video. So, the distance matrix with respect to the number of charged-off loans for different states are shown below. I only shown the first 5 states, but this is essentially a 51 by 51 matrix. After we create the distance matrix among different states, we proceed to perform a hierarchical clustering based on these distances among the states. In this case, we cluster the states based on the number of charged-off loans in each state. As you can see from this dendrogram, the horizontal axis refers to the number of clustering solutions. Here, they can be 1 cluster, 2 clusters, 3 clusters, or even up to 51 clusters because we have 51 states here. And the vertical axis refers to the distance when 2 clusters are combined to form a new cluster. As you can see, some vertical distances are longer than others. So, it's possible that we can get 1 cluster, 2 clusters, or even up to 51 clusters. We are going to ask a no-brainer question. What's the optimal number of clusters that can provide the best insight into the hidden structure of the data? In other words, what's the optimal number of clusters that can best explain the data? There are many ways to determine the optimal number of clusters that best explains the landing club data. And one of the famous one, or the most often used, would be the elbow method. So when we use the elbow method to determine the optimal number of clusters, it seems that there's an elbow at 2 clusters. As you see from this diagram, the total within clusters sum of squares drastically decline from 1 cluster to 2 clusters. And the decline is lesser as we proceed from 2 clusters to 3 clusters. The decline is also lesser when we proceed from 3 clusters to 4 clusters. And the decline is almost stagnant when we go from 5 clusters and above. And there's an obvious elbow at 2 clusters. This is where we see a significant decline in the total within cluster sum of squares. Another method that can be used to determine the optimal number of clusters is the Stillhart plot. As is the case with the elbow method, the Stillhart analysis suggested 2 as the optimal number of clusters for the landing club data. Because we want to be more certain, we proceed to use another method, the Kolinsky criterion, to determine the optimal number of clusters for the landing club data. And the Kolinsky criterion suggested that 10 is the optimal number of clusters for the landing club data. Let's go back to this diagram again. This is the one we use the elbow method to determine the optimal number of clusters. When the elbow method was used, we saw an elbow at 2 clusters. However, we also see that the total within clusters sum of squares continue to decline slowly as the number of clusters increase and is stabilized after 5 clusters or so. So, to find a more meaningful clustering patterns, we may not want to use 2 clusters. We can use either 5 or 10 clusters to see if we get a more meaningful clustering trends among the different states in America in terms of the number of charge-off loans. So, I initially started separating the 51 states into 5 clusters, and when I separate the states into just 5 clusters, I saw that the clusters are very unevenly distributed. There's only 1 or 2 states with their own clusters, and the rest of the states are being lumped into a big cluster. So I proceeded to separate the states into 10 clusters, and this is what I found. As you can see from this dendrogram, when we split or separate the 51 states into 10 clusters, this resulted in 3 moderately sized clusters. And we also see 3 clusters consisting of 3 to 4 states. And we also see the remaining 4 clusters consisting of one state each. So, as you can see, states like Maryland, Arizona, and Michigan, their trends with respect to charge-off loans are somewhat similar. The same thing can also be said for Ohio, Illinois, New Jersey, and Pennsylvania. Their time series trends with respect to the number of charge-off loans are similar. And as you can see from this diagram, states like California, Florida, New York, and Texas, they form their own clusters. So this tells us that these four states have their own distinct trends with respect to the number of charge-off loans. So, the trends with respect to the states are more evenly distributed if the states are separated into 10 clusters instead of 5. So I decided to use 10 clusters in this case. As you can see, the clusterings of different trends can also be displayed in this format. And sometimes this format may be clearer. And as you can see from this diagram, each color represents a different cluster. So as you can see, states like California, Florida, Texas, and New York, they form their own clusters. And states like Georgia and North Carolina, or maybe Virginia, they form another cluster. Their trends looks almost similar, and therefore they form another clusters, and they are represented by the color blue. And states like Hawaii, Iowa, or Idaho, they form another clusters, and there's essentially no trend. There's essentially no charge-off loans in this state. They are looking quite good, and they form another cluster represented by the red color.